In this lesson, we're going to look at finding the area of a sector. Now, before you can find its area, it's helpful if you understand exactly what a sector is. I'm going to encourage you to think about a sector like a slice of pizza or a slice of pie, or maybe even think about it as being kind of a wedge in that circle. But in my little sketch that I just drew up at the top of the page, the red slice of the pie or the red slice of pizza would represent the sector. When we find the area of a sector, what we're actually going to do is we're going to find some fractional part of the area of the entire circle. And the way we do this is by taking a look at the ratio of the central angle of the sector to the central angle of 360 degrees, or by comparing the ratio of the arc length of that sector to the entire circumference of the circle. And again, it's easiest to remember when you're doing this that what we're really dealing with here is fractional parts. So I'm going to think about this as doing part over the whole over part of the whole over the whole, where my wholes and my parts consists of central angles, sector areas, and arc length. For instance, I might compare the measure of the central angle of the sector to the entire 360 degrees contained within that circle. Or I might compare the sector area to the entire area. Or perhaps I would compare the arc length of my sector to the entire circumference. But every single one of these ratios compares some part to the whole entire circle. So if we keep this idea in mind and jump right into example 1, in this question they're asking us to find the area of a sector whose central angle has a measure of 60 degrees and whose radius has a length of 10. They want us to express our answer to the nearest tenth. So they labeled this 60-degree central angle in the picture, but they didn't label the radius length of 10, so I'm going to go ahead and start by labeling that. And again, I want to think about the part that I'm going to compare to the whole thing and the part that I'm going to compare to the whole thing, where my parts and my wholes are going to come from this extended ratio that I wrote up in the very beginning. So in this case, I'm dealing with a central angle. So a central angle of 60 degrees is compared to the entire 360 degrees in the circle. I'm trying to find the area of my sector, so I might say let X be the sector area. And I want to compare that sector area to the area of the whole circle. Well, we don't know what the area of the whole circle is. However, we certainly do have a formula for finding the area of a circle. Our formula sheet tells us that we can find the area of a circle by multiplying pi times the square of the radius, or in this case, pi times the square of 10. So the entire, or the area of that entire circle in terms of pi would be 100 pi. At this point, I'm set where I can either go ahead and cross multiply, or I might find it easier to simplify that fraction first. So I'm going to go ahead and simplify that or reduce it down to 1 over 6 is equal to x over 100 pi. And then I can go ahead and cross multiply. 6x is equal to 100 pi. And therefore x, or the area of my sector, is going to be to the nearest tenth. I would need to get my calculator out, and into my calculator I would substitute 100 pi over 6. And when I do that, I find that the area of my sector is about 52.4 square units. All right, so there's the first one. What you're going to find is that all of these work exactly the same way, where we're comparing parts with wholes, whether they're central angles, sector areas, or arc lengths. So in number 2, it says find the area of the shaded sector. So again, I might say let X be the sector area. The radius of this circle they've labeled with 6, and the central angle of this circle they've labeled with 100. So again, I'm going to compare parts with holes and parts with holes. And in this case, again, I'm comparing angles. So 100 degrees out of the entire 360 degrees. How does that compare to my sector area over the area of the whole circle? And again, they don't tell me the area of the whole circle, but this is a fairly simple, quick, and easy computation for me to make. So the area of the entire circle in terms of pi would be 36 pi. And again, I'm going to go ahead and I'm going to simplify this fraction. And when I punch those numbers into my calculator tells me that that fraction will simplify to 5 over 18. And it just makes the numbers that I'm working with a little bit more manageable. So when I cross multiply, I get 18 times the area of my sector is equal to 5 times 36 pi, or 180 pi. And this one also, they want me to round to the nearest tenth. So I'm going to go ahead and divide both sides by 18. And when I round to the nearest tenth, I'm just going to type into my calculator the entire fraction, 180 pi over 18. And to the nearest tenth, I end up being about 31.4. And this time they do tell me inches, so I can go ahead and be specific and label that square inches. Number 3, they don't give me a picture like they did with the first two. So if you're a very visual person and you find it helpful, go ahead and draw a picture. They tell you we're looking at a sector. So there's my sector. We're trying to find the area. So once again, I'm going to say let X be my sector area. But this time they tell me that the arc length is 40. So in other words, that curved wedge of my pizza there is 40 centimeters, and the radius is 12 centimeters. So unlike the first two where I knew that central angle, this time I know the arc length. My strategy, however, isn't going to change. I'm still going to compare parts with holes and parts with holes. But this time I'm going to compare this arc length of 40 centimeters with the entire circumference of the circle. And again, they don't tell me circumference, but it's a fairly easy thing to find if I use the formula that's given to me on my formula sheet. So a radius of 12 would be a diameter of 24, making the circumference of this circle 24 pi. And it's going to equal the part, which is the area of my sector, over the whole area of the circle, which I do need to go ahead and compute. But I've done this a few times now, and I feel like I'm getting pretty good at it. So the entire area of the circle, 144 pi. So I'm going to go ahead and I'm going to cross multiply. I'm going to type into my calculator 40 times 144. So when I do the 40 times 144 going in that direction, I end up with 5,760 times pi is equal to, in the other direction, 24 times pi times x. And now I'm going to go ahead and, in order to isolate the x on the right-hand side of my equation, I'm going to divide both sides by 24 pi. And in this case, I'm simply going to get my calculator out. I'm going to type in the fraction where 5,760 times pi is in the numerator, 24 times pi is in the denominator. And my calculator tells me that's equal to 240. And my units here are centimeters. So the area of that sector would be 240 square centimeters. In the last example that we're going to take a look at up at the top of the next page, they don't give us a picture either. So the very first thing I would do is I would draw a picture. If the name of the circle is O, I know the center of the circle is at O. They talk to me about diameter AB. So I'm going to go ahead and draw that diameter that passes through the center on my paper. And the length of that diameter is 15. I'm going to label the radius as 7.5. And the measure of angle BAC is 65 degrees. So I've got to put C somewhere on the circle. Now I've got angle BAC. His degree measure is 65. And I do know that if I have an inscribed angle that's 65 degrees, I know that the arc that goes along with that angle must be double that angle, or 130. So even though that information isn't directly provided to me in the problem, I do know that the length of that arc is 130 degrees. They want me to find the area of sector BOC. So in other words, that blue wedge, or that blue shape of piece of pizza, to the nearest tenth. So I do know that if the length of this arc is 130, then the degree measure of the central angle that accompanies that arc is also 130. So when I go to set up my parts in my holes, I have a central angle of 130 over an entire circle of 360 is equal to x, which I'm going to let be my area of my sector, over the area of the entire circle. So again, I'm stuck computing the area of that entire circle, where in this case the radius is 7.5. I didn't do this in the previous example, but you can go ahead and simplify that fraction, which will make the math or the computations that you do just a little bit friendlier. And again, it's a matter of cross multiplication in order to solve. The cross product in one direction is 36 times x. The cross product in the other direction is going to be 731.25 times pi. I simply got my calculator out and multiplied the 13 times the 56.25. In order to get x all by itself, I'm going to divide by it. So x, or the area of my sector, is going to be whatever I get when I get my calculator out and I type in the 731.25 pi over 36, or in this case, 63.8 square centimeters. All right, so that's pretty much it on area of a sector. Really, it all boils down to this comparing parts with holes. Again, whether it's central angles, areas, or arc lengths. As always, I do want you to take a few minutes and reflect upon what you've seen, and in your own words, summarize the key ideas and important understandings, and then see if you can use what you've learned in order to solve those questions down at the bottom of the page.